Hello, everyone. We'll be starting shortly at 11:05 for this webinar. Thank you for joining in. Okay, it's 11:05 Pacific Standard Time. I'll be starting the webinar. Thank you for joining everyone today. Today's webinar is deploying enterprise solutions across energy. For those people that are asking, the webinar is recorded and you will be sent a URL link to watch it after the webinar is concluded. It takes a few hours to process and you'll be sent that. We ask that we do have a question chat box. So if you guys have questions, feel free to submit that. Feel free to also put at Michael, Jeff, Brian, or Chad so that we kind of know who it's kind of directed to. Today, the three of us will be able to present each of our slides and show a little bit about some of our use cases in our equipment. So I'm going to go ahead and get started with my slides. My first slide is an introduction to the team. So I'm going to introduce myself. My name is Michael Lee. I'm a solutions engineer at DJI. I focus on the oil and gas and energy side of enterprise drones. I've been at DJI now for almost 5 years. I've been helping a lot of customers either develop and understand their drone program. Yeah, I'm looking forward to presenting some of my information to you today. I'm going to let Brian now introduce himself.
My name is Brian Moss. I am a field engineer at Columbia REA. I specialize in overhead and underground utility infrastructure design. Been doing this for about 17, coming up on 18 years. So I mostly have worked for cooperatives and public power.
Thank you. Chad, if you want to introduce yourself.
Hey, good morning, everybody. Chad Nelson here. I am the Chief Pilot and VP of Safety for US Air Unmanned. I've been in the drone industry for going on about 20 years now. Our US Air Unmanned is pretty new overall. Started about 4 months ago. Prior to that, I was with Genpack Drones, so quick shout out to them. Great company if you're looking for any equipment. And I'm going to pass it on to Jeff.
Hello, everyone. My name is Jeff Chaffa. I am Chief Operating Officer of US Air Unmanned. My past experience with UAVs, sensors, etc. I was program manager for the UAV department in Alaska on the North Slope for a major oil company. Prior to that, I have flown pretty much about everything UAV wise on everything from 3D modeling for comm towers, for 5G upgrades, and a myriad of different things. So there you have it.
Thank you. Awesome. Each of these gentlemen will have an opportunity to present some of their slides and talk about their use cases and software and equipment. For now, I'll have them mute themselves and just go ahead and turn off their camera so that I could go on over my slides. Jeff, if you could turn off your camera, please. Thank you. Okay, so the contents of my slides, this is only for my slides itself, is I'll be covering over DJI Enterprise products. So that'll include the Dock 3, the Matrice 4D, the 4TD, and the 4E and 4T, and the Matrice 400, and some L3 and the new L3 payload and some use cases. So to give you guys a little introduction, one second. Sorry, my slides are having some technical difficulties. Give me 1 second. Stop sharing my screen. Perfect. Are you guys able to? Yes, I think everything's good now. Okay. So the first DJI dock we had was the Dock 1. That kind of began our journey in the box and the solution at DJI. Then Dock 2 followed with the smaller footprint, and it was overall tougher, small but tough. And now we have our DJI Dock 3. So that kind of formed a version of between the Dock 1 and Dock 2 that combined into like a medium size. So going over some of the specs from the previous Dock 2, we did have a slightly bigger dock in comparison, about 55 kilograms and a bigger dimension. We also increased the operating temperatures, specs, increased IP rating, max allowable landing wind speed. So things just got overall better. The charge time was also decreased from 15, a decrease allowing 15% to 95% and only 27 minutes. So some of the use cases I've seen with the Dock 3 being used currently right now, this is an example of pipeline inspections and saltwater leak use case in the oil and gas industry. We have underground water transfer lines. When they do have a leak, you're able to essentially inspect the vegetation in the nearby area to see if that leak is happening. Also for buried lines, we were able to inspect them and assist for watching for any vegetation loss. And then above ground or new leaks, you can use the dock to use that for any thermal imaging detection. So how they did this, these pipeline inspections and saltwater leaks, was a pretty simple workflow that they used. As you can see here, they created a linear mission over the pipeline in FlyHub 2. And then they were able to, once that mission was completed, they were able to upload those photos into either an AI third party to inquire for leaks and kind of ask the AI if there was any leaks or any moisture. They're able to even build models in FlyHub 2 and use change detection and essentially see the difference between them. So you guys can kind of see in this slide right here, the change detection between the two models. And they were able to also use a smart search in FlightHub 2 to look for any issues such as searching for leaks or moisture also too. They were also able to use the Dock 3 for any equipment inspection. So the Dock was able to help check gas meters for any integrity, tanks for levels and spills, and also inspects the separators for leaks or smokes, flares for any flames, and then wellheads for any vapors. So for this use case, they were able to essentially use the virtual cockpit in FlightHub 2 to control the drone and take off. And they were able to use side by side to get visual and thermal at the same time. And they were also able to save annotations and any media all saved within FlightHub 2. So this is kind of like a sample that they would see in FlightHub 2 while flying a view. Another use case within the pipeline inspections and saltwater leaks involves drilling completion. So that's going to be pad preparation. They're able to inspect these rigs for safety and operational details. So this phase includes a lot of challenges and is pretty costly. So you can see in this photo right here, they were able to create a model, but kind of showing you what they did was they were in FlightHub 2. They were able to create a simple route around the drill rig, and they were able to generate a model to kind of have different models and inspect it over time. And then on top of that, they were able to take panorama photos around the drilling rig. So you can see this panorama photo right here in FlightHub 2 is pretty useful. Okay, going into the Matrice 4D, the 4TD, the 4 and the 4T and the 400. These are kind of our drones we have on the Enterprise. So going over the Matrice 4D and the Matrice 4TD, this is the one that's inside the Dock 3. And then we have the Matrice 4 and the Matrice 4E and the Matrice 4T, which is very similar to the Dock 3 drone, but this is more of the entry-level Enterprise drone. And then we have our flagship Matrice 400 RTK. That's our biggest Enterprise drone we have. So going into the 4D and the 4TD, reminder, this is the drone that's inside the Dock 3. So this one is the 4D. So you can kind of see some of the specs that it has. So we have a tele camera, a laser rangefinder, a mid tele, and a wide angle camera. So you can see we have 3 visual cameras and a laser rangefinder. Going into the 4TD, the main difference is having a thermal camera. So the thermal camera you can see is on the top left, and then you have your mid telecamera on your top right, telecamera right below the thermal camera, and the wide angle below, and a laser rangefinder and a near auxiliary light on the bottom right. So you'll notice that the 4TD does have the thermal camera and the near auxiliary light. With that, we kind of downgrade the wide camera from the 4D. So we lose that 20 megapixel true resolution mechanical shutter that the other one without the thermal doesn't have. So this is a quick video of the Dock taking off and being controlled in virtual cockpit. So if you're not familiar, this is our software called DJI FlightHub 2. It's used to control the DJI docks. So in it, you can plan missions, you can fly missions, you can get a live view, you can stream, you can do all sorts of manipulation essentially to control the drone. So you see you can move the camera, take photos. Okay, going into the Matrice 4 and the 4T, some of these features you'll see are very similar and also available in the 4D and the 4DT. Now the Matrice 4E and T, we offer features such as AI to detect people, vehicles, and boats. We also have a zoom now that goes up to 112 times. We've improved low light for better obstacle avoidance, night scene modes. We have precise mapping, also faster and safer takeoff. And then the range of the drones have increased significantly too now with the 25-kilometer transmission with their new OcuSync technology. Some upgraded accessories are going to be gimbal follow with the spotlight. We'll have real-time voice speaker. So these are two accessories available. So, and you can also now use both of them at the same time. So you can kind of see in this photo right here, the spotlight and speaker on top of each other. And you can also just have one or the other. So for example, if you only wanted the speaker, you could ditch the spotlight and use the speaker, or vice versa, use the spotlight and not use the speaker, or use both of them at the same time. So some key specs with this drone is that 15-second fast takeoff speed, 10 meters per second ascent speed, 21 meters per second forward speed, and then 25 kilometer transmission range. So these are some specs: 8 meters per second maximum descent speed, and then 49 minutes flight time. So increased by 6 minutes from its predecessor. So a use case I've seen with the Matrice 4 is powerline inspection. This is really popular. The Matrice 4 is able to scan for any hotspots using that powerful IR camera. Advantages, let's see if there's a video plays. The cruise control is used for steady speed. You can see auto temp alarms being adjusted in this video. And then obviously, you also have visual at the same time too. So you can see pretty powerful small drone that's able to accomplish a lot for these powerline inspections. Okay, going into the Matrice 400, this is our flagship, biggest drone we have on our DJI Enterprise side. So with that, we're going to have multiple payload capabilities. So that's going to include your H30, your P1, your L2, S1, V1, and now the new Manifold 3. So some powerful specs are going to include 59 minutes of flight time with the payload. That's pretty impressive, almost about an hour with the camera. You have 25 meters per second flight speed, 6 kilogram payload capacity, and then that 40 kilometer range with that OcuSync technology is pretty impressive too. You have real-time terrain follow, and then you also have now able to ship-based takeoff and landing with the M400. So a use case I've seen with the M400 is using the powerline follow feature. Let's see if these videos will work. They're able to cover lots and lots of power lines using the L2 and the L3 for the powerline following feature. They're able to also bypass any obstacles and utilize any dual drone for a mountain relay. So a new feature on the 400 is they're able to use a relay to increase signal. So you guys can kind of see in this video right here how the relay works for the M400 if you have more than one M400. So that's kind of the end output you can see in DJI Terra, this beautiful point cloud. Okay, going into the Zenmuse L3, this is a new advanced LiDAR that's very impressive with 16 returns, 950 meter range. These are some of the new specs. As you can see, 16 returns, 950 meter range, but these are some of the big highlights for the L3. So some use cases I've seen with the L3 now is in Canada, they're able to use it for vegetation penetration for power line surveys. So some of the previous challenges with the L2 and the L1, they kind of struggled with density with maybe certain blocked areas. With this L3, that was not really a big issue. Terra was able to collect data with pretty good deliverables. So these are some of the specs these are some of the data capture and mission planning that they were able to successfully complete the mission. You can see the altitude and the speed, the overlap, they did it 50%. They did 2 lines either side of the power line. And then they were able to capture using this point frequency and scanning mode, so 350 kilohertz and star with 8 returns. So this is a new scanning mode that was selected for better accuracy and penetration. Flight time took only about 10 minutes. One of the features I did want to highlight too, so this was the end result right here, the data processing output. So they were able to utilize DJI Terra to generate these point clouds from the raw data, and then Modify is also available for any classification and refinement. And then Trimble Business Center was used for final output. So the L3 was able to provide all the required penetration to extract required features for the season in Canada, and this allowed for the operations to go on throughout the entire year, not just in spring and fall when they didn't have much leaves. One of the features I wanted to point out was ground point classification. So this is kind of useful in certain use cases where basically the data is being processed. We're able to automatically identify and isolate the ground and remove non-ground features such as vegetation, buildings, trees, vehicles. So you can kind of see on the top right here, this kind of how the white stuff is essentially buildings, everything that's not the ground, and we're able to just completely wipe that and see just the ground terrain, making it easier. So some applications are like generating digital elevation models, all different types of terrain or whatever that may be. So pretty useful tool for that ground point classification. So that kind of concludes my slides for today. I'm going to pass it over to Jeff and Chad, where they'll talk a little bit more about their use cases. Let me give them sharing ability real quick. Oh, looks like Chad already has it.
I don't have sharing ability yet.
Okay, should be good to go.
Perfect. All right. Michael, is that showing up clear?
Yep, everything looks good. Your camera looks good. Your screen looks good. You're ready to rock and roll.
Perfect. All right. So sensor applications on the DJI platform in critical infrastructure, real world oil and gas methane detection and power line inspections is basically what US Air and Manned does. We do it along the North Slope and throughout the lower 48 as well. We have contracts with some of the largest oil companies on the North Slope, and also do a number of other drone operations that if you ever reach out to us, we can discuss those in the future. In our oil and gas, one of the biggest things is methane detection. Of course, with this, we use the 300 and Matrice 350 paired with a U10 methane sensor. Overall, short duration inspection flights with high detection densities allow us to find where precise leaks are. We can also configure the threshold for the detection so that we're not getting a ton of erroneous data. Generally, oil and gas companies are more interested in leaks that are in the thousands of parts per millions versus the hundreds. And so overall, being able to tune that laser down in order to detect exactly what you're looking for helps filter out a lot of the erroneous data that's not important. Here you can see with the U10, we have the A1 inspection report. A1 is their software that generates the inspection itself. You can see our flight path here. During this particular mission, we did not have it tuned because we were specifically looking for not just leaks over a valve, which we'll be able to show you where that valve was and where that leak was. Of course, the imagery here is old GIS imagery, so it doesn't show the valve in the image itself, but we can show where the pinpoint was. But we were looking for that, and then also fissures where there might be natural methane leaking out of the ground, which we did find in the actual riverbed, which was pretty interesting. Moving on to the next slide. Field results, wide concentration range detected in a single mission. For this particular mission, low, moderate, and high methane plume identifications and georeference alarms enables rapid ground verification to be able to deploy teams to the exact location where the issue may be, whether it be along a pipeline or valve or pump station or any of the other equipment within the oil and gas industry. So here you can see we've got a hit at 2,640 parts per million. In this software, it's going to show all the different hits, but the hit right at about the center of the image is where that hit is actually coming from. And then here you can see, the range that we're looking at. So from 36 parts per million, that was probably one of our lowest hits that we had that day. And again, that's going to be around the center of the image is where that particular hit is calling for. You can't see it right now because this just shows all the construction that was there prior to the valve being installed, but the valve was right about here. Moving on to the next slide. So why sensor configuration matters, as mentioned before, the threshold settings directly influence the detection sensitivity, allowing for adaptation to background conditions, whether it be wind or, fissures and other things of that nature. This ensures actionable and not overwhelming results. Another application, this is used with the H30T within the oil and gas industry, is especially up on the North Slope where temperatures range between 50 degrees down to -70 sometimes. We've got here missing insulation, so insulation inspections along the pipelines, and you can see thermally where those issues are, and then also visually with the zoom camera on the H30T and the side-by-side images really help out during operation. These operations are generally manually flown, and as you can tell, this pipe is kind of behind this pipeline, and as you can see down here, this is the actual roadway. So from the roadway, visually, you would not ever be able to see that missing insulation. Of course, on this main pipeline, you would on the higher picture, but behind that, again, you're not going to be able to see that missing insulation from the roadway. So this is really key to be able to get aerial footage quickly and easily without having to deploy a manned aircraft, a helicopter, or a Cessna of any sort, and also much cheaper, safer, and can operate in more adverse conditions as well. So some of the field lessons learned: wind impacts gas detection more than altitude. Of course, the altitude is a factor overall. There is a max limit where the U-10 will not be able to detect anything, but the wind is going to generally disperse those plumes, and you're going to be getting hits all over the board, and identifying the exact location of that leak could get quite tedious. And so for that, one of the things that we do is we use the Ventus OGI, or 640 OGI, that will help us visually through gem mode, gas enhancement mode, view where the actual plume is coming from. Quick shout out to Linkdal. They've helped us not only get demos of the Ventus 640 OGI, but they also are who we purchased through for any of that equipment. Great team there. If you're needing to contact anybody, get a hold of Juan Ayala. Repeatable flight paths create long-term asset value, and of course, experienced operators can unlock the full value of all of these sensors. On to power line inspections. Transmission and distribution infrastructures, insulators, hardware, conductors, all performed without having to do any planned outages or climbing crews. The H30T itself allows us for capturing superb data collection and safe standoff distances up to 50 feet from the asset. Here in these images, you can see we're probably, I'd say, more along the lines of about 40 feet from the asset, but we have our wide angle shot, we have our zoomed in shot at about 15 times, and then we have our zoomed in shot at around 30 to 40 times zoom. And you can see here we've got a missing bolt, nut on this through bolt for the cross arm brace here. Our power line inspections are generally going to be visual, RGB, and thermal inspections, where we look for hot spots, within the utility corridor. And one of the softwares that we like to use generally up on the North Slope, which we might be changing over to Polehawk by Wiggins Tech, their software allows for not just RGB and thermal data and reporting, but also allows for being able to have all of your georectification LiDAR data installed there as well. And I do want to mention we do use the L2 as well, and unfortunately for most of our customers, that data is fairly sensitive, and so we were not able to get permissions to share that. Moving on, here's the flight path of one of our flights, and you can see we took 9 images at each individual location. That's basically our general shot list. And unless we need to take extra images due to something really sticking out in real time. Of course, this key AI data or key AI software is able to take all of the data that we've input and slowly learn more and more along the lines of exactly what failures and issues we're looking for. And so as the longer you use it, the more information you feed it, the better it gets at detecting any of the issues. So here's one of the detections that it was able to highlight. So we have some hot spotting on some jumpers here, and you can see them. They've got about a 30-degree temperature difference from the rest of the circuit and equipment there on the circuit. Next, it was able to locate some missing hardware, missing cotter pin on this insulator, and you also notice you have the image geolocation information, so that when you go to send crews out, you give them the exact location, and it also tells you which line and pole number it is. So in case for some reason a pole is mismarked or the tag's off of it, they can always back reference to the geolocation of where the image was taken from. Of course, that geolocation information is where the drone was, not so much where the where the actual pole is, but it does help quite a bit. Here again, you see some more missing hardware, missing nut and pin, cotter key on this pin. Here you can see where there has been some movement within the insulator. This is due to the huge temperature differentials throughout Alaska. I've even heard of poles moving up to 10 feet before from other utility companies, not any of our customers, but some utility companies have mentioned that to me back when I was with General Pacific. This particular pole, you can see that it's shifted a little bit, the pole on the left-hand side, which is causing that insulator to offset quite a bit, putting unnecessary tension on there. So this will allow for a crew to go out and reset that insulator or reset that pole. Here, the software was able to detect some arcing, possibly due to loose coupling within that conductor or some moisture gathering in there. Hard to say without actually getting some physical hands-on and eyes on the situation, but that's what it looks like to me here. And then of course, it's also able to detect debris. Debris are a big issue up on the North Slope with it being the tundra, and on the Arctic Ocean, we get a lot of overspray, salt overspray and dust that accumulates, and then also avian debris from their crapping on the lines and the insulators and poles and things. So all those kind of give a little bit of an issue in terms of the insulator operating correctly and no no arc jumping anywhere. Other payload applications, again, the 640 is, the OGI 640 by Ventus is one of the ways that we isolate and detect where the plumes are actually coming from. Again, the data that we have is sensitive to our customers, so some of these images here are just images that LinkDAL has provided of sites where they don't have an issue sharing that information. But you can see here there's the plume leaking. This is gem mode, or the gas enhancement mode, where it actually enhances any movement that it's seeing. And then of course this, where you see the dark black here, this is black hot. And that's just a regular image without the gem enhancement mode. One issue that I have seen with the gem enhancement mode is if it is really windy and the aircraft is moving around a lot, it starts to kind of highlight everything in the image. So sometimes running that gem enhancement mode doesn't really work out all that well for us. So we just have to train our operators to, visually detect what they're looking for in general. Then we have our ground penetrating radar. We use this to locate underground utilities and facilities prior to excavation and or drilling for either setting new utility lines or also drilling any new wellheads. That way we don't strike anything that we weren't sure is there, because overall these systems have been up there for quite some time, and over the past decades there's probably not some of the best GIS data locating exactly where all these utility lines and different things are there. Also, we use a flamethrower. This is probably one of the funnest aspects of our missions up there. The flamethrower is via CZI, and traditionally we would have to light pilots that the igniters had failed on by shooting flares up into the flare stack, or at the flare stack if it was a horizontal stack, to try and get that pilot to light. And not only was that tedious, but it also maybe not the safest route. This allows us to be able to get right up to that pilot light, get it lit in order to get that flare back online so that pressure can be redirected quickly, because generally when they need to light off a flare, it's usually because they need to redirect pressure for an emergency situation. So cross-industry takeaways, same DJI aircraft and platform, well, between the 300 and 350. We can't wait to get our hands on the 400 and the L3, I will say that. But multiple sensor applications, oil and gas, utilities, all share common operational challenges when it comes down to weather considerations, sorry, I can't speak right now, and also safe standoff distances to critical infrastructure. And of course, reliable data depends on sensor quality and the configuration. In closing, the DJI platforms allow for multiple sensors, deliverables, actual field data, much easier to fly than most of the other aircraft out there, which is one of the reasons why we love DJI. Flies in more adverse conditions than most of the aircraft that are out there, as in drones. And with proper configuration and experience, you're able to get the job done. Thank you guys for your time, and let us know if you have any questions.
Awesome. Thank you, Chad. Now we're going to move on to Brian, if you want to. Yeah, perfect.
There you go.
Let me let you share your screen really quick.
Mm-hmm. Screen share. All right. So good morning. My name is Brian Moss. I am field engineer, like I said, at Columbia REA. We are a small cooperative in southeastern Washington, and I've known Chad for a couple of years, and I blame him. He's the reason we got into this. So I met him when we were working at Genpack.
I'll take it.
A little bit about us. My presentation is going to be slightly different than those before me. We're definitely going to be taking more of an energy look at this from kind of a utility standpoint. So for what it's worth, slightly different industry. Little bit about us. We're a member-owned cooperative. We got not quite 7,000 meters, but we're very spread out. We have just a tick over 4 meters a mile. So when you consider the several, couple 600-700 miles of line we have, something like that, it's pretty spread out. We have distribution and transmission both that we have to keep track of. And importantly, we're the top of our service area is not just, we're a little over 4,000 feet. So getting something that could definitely make that elevation all the way to the top was important to us. To that end, get here. I've been doing this for 17 years, and historically cooperatives are not the most tech savvy place where you wind up. So the fact that we have a drone was a bit of an oddity. When I first started working here, we were using a transit and a steel chain. So we would get a very archaic device out. This is how we were surveying in lines, trying to find stuff. Designing utility lines with this, any measurements that were critical that we needed to take, it was done in this manner. We upgraded total stations. For those of you kind of familiar with how surveying total station operates, same basic concept, but now it has an EDM or an electronic distance measuring device, fires a laser, takes a shot. We about not quite 8 years ago got on board the GPS revolution. So we have a sub-centimeter GPS. And for a while we were there, and when I ran into Chad was like, "You need to check this out. This is something that could be a potential game changer for you guys." And we got our first drone about 1.5 years ago, and it has been quite the game-changing device for us, just in terms of design and how we're using it. The important part about this, how we're collecting data, is it comes down to man hours, right? So when you're setting up to do design work and you need to take shots on fire hydrants or trees or people's fences or just whatever's out there in the world that you're trying to design power lines around, getting accurate, detailed data on that so that you can go back to the office and figure out where utility easements need to be, or how you're going to fill out a permit if you have to cross railroads or county roads or state roads or whatever's going on. If you're literally taking these points where there's 2 guys and somebody has to walk out there with a stick while the other guy hits it with the laser EDM, data becomes very expensive to collect. Even with the GPS, that's still putting a person on the end of a stick, and he's out having to go to all these points. With the drone, we can take 320,000 points a second as we fly over the top of an entire project. In a couple of minutes, we can achieve what would take us 2 or 3 days, depending on the density or the type of the project that we were working on in terms of that. So from a let's get some data, the drone has been an absolute game changer in that respect. I'm going to focus on 3 use cases at our co-op that we've come across with this. These are by no means the full breadth and width of what we've used it for, but I think these are probably the most accessible. So we're going to talk about how we did some transmission comm attachments, a little overhead pole design I'm going to focus on, and then last we'll talk about some avian or bird concerns that we were able to use the drone to figure out with. Real quick, I'm going to second what Chad said. Can't wait to get my hands on a Matrice 400. Currently, we are flying the L2 LiDAR package with the Matrice 350 RTK. The RTK in this instance stands for real-time kinematic. So we are able to GPS fix all the data points that we are collecting and bring those back in and have those geo-reference into our GIS software, our mapping grid, and mostly communicate with other engineering firms in the area fairly accurately where things are at. We do have an H30T, and I absolutely love the ability to go up and get some real good, sharp, crisp pictures. We have used the thermal on it before. I've got nothing but good things to say about it. I will say, as a design tool, that L2 LiDAR is the meat and potatoes of what we have it. And the data that we're collecting off of it is, I can't talk about how much time saving that has put in front of us. Briefly, Michael touched on the L3 LiDAR that has come out. I've gotten to play around with some of the data that's come off the L3 LiDAR. I'm here to tell you it is amazing, and the amount of data that this thing can collect in one pass is, it boggles the mind how it loads it that fast onto its internal storage device. The L2 is insane with how much it can collect in one shot, and the L3 is somehow a step above that. But having said that, this is kind of the first use case that I wanted to chat about. So this is a transmission line that exists inside of our system. It's around 4 miles in length, and we had, give or take, about 60 towers somewhere inside of there. And when this transmission line was built, we had a underbuilt communication line that was attached to it. So this is not uncommon. There it is right there. This is a picture of it. That is a fiber optic communication wire that was placed underneath of the line the whole way through. So it starts at one end and rolls all the way to the beginning. So when the manufacturer called us up and said, yeah, that's not going to work, it's fallen apart, and lo and behold, we had gone out and found that there indeed was issues, we were going to have to replace that line, which was sad because it was only about 5 to 6 years old. So having to go out, pull the new one or pull the old one off and get ready to put the new one back on. When we did that, we started looking up, okay, how do we want to attach that to there? What kind of ground clearances are we looking at? How does the old line sit in there so that we can sag the new line in to fairly approximately fit that? Well, when we built the transmission line, this was a guy's job, and it took him the better part of 2.5 days. This picture doesn't show it incredibly well, but right near the center of the picture, there is a giant swamp land that is nothing but, I had to drive through it once in a side-by-side. It's not something that I would want to have gotten out of the vehicle and had to spend much time in my mud boots figuring out how to do. So we went ahead and threw up the drone, and it was amazing how fast this thing accomplished the mission. So let's see if everybody can see that. Pull this out of the way. Here we go, DJI Terra. So this is DJI Terra. This is the software that comes along. You get this for free with the LiDAR package. Effectively, you can load the data directly into it. And what you're looking at here is the scan that we took. The drone flew for about, I'm going to say, 17 minutes. It was able to accomplish all 4 miles of this in one pass. So this is the entire project of the transmission line, stem to stern, the whole way through. And the astute among you will notice there's the high line, we've got the 3-phase conductors, and then under here we have our fiber optic line. Somebody would generally have to go out and they would have to take a insulated hot stick with marks on it. They would have to run this up and measure the whole thing. We figured out pretty quickly how we could go in and with just out-of-the-box software, nothing particularly special about it, we went in and did this. Each one of those red marks is a measurement tool that we were able to handle inside of the software. And so we went in and we measured the attachment height on the tower, so ground to tower, and then we went and we measured the height to ground. And I know these are drawn at a bit of an angle, but when I show you the data here in a minute, it'll actually give you the vertical clearance instead of the slope distance. It gives you several pieces of data. So we took that and we did this over the whole line. So as I said, it took about 20 minutes to fly the whole line. By the time you got out, set the drone up, flew it, landed, put it all back away, call it half an hour from start to finish. This data we were able to collect, came back to the office and completed it in less time than it would take to do just a handful of polls in the field by hand. When we were completed, you got this list right here. We can export this list, and I'm going to see if I can show this here. We exported this list and we're able to output the data into a table, and it gave it to us. Here's your clearances. There's your vertical distances right there. Put it up in a table, put the names on it, and we're done. It was that fast. When we completed that job, we realized that some of our GIS mapping data was just a touch off, and they were like, "Hey, can we geocorrect some of those pole locations off that?" So DJI has built in where you can make a mark and then do the same thing. You can export a table, and so we did exactly that. We exported a table that gave all new X and Y locations in state plane coordinates for our transmission line. Handed that over to the GIS department, and they were able to correct all of our pole locations in map. And so we kind of got a little more bang for our buck out of that. This is not by far and away not the most sophisticated thing we do with it, but this was a pretty good example of you can go in and you can get a lot of data very quickly, and then one guy can sit in the office and process that data to get specifically what it is that you're looking for. Funny story, and very brief. This right here is the only tree in about 10 miles on this project. And it just so happens that we caught a tree trimming concern in that one flight from the only tree that is forever away. So anyway.
Hey, Brian,
next,
question. How long would staking all of those measurements out with a hot stick take along that particular circuit in general? What is your time savings there and manpower savings?
For when we initially did it and sent somebody out to go do it, we were probably 2 days, 2 days into it. That's somebody had to get out there. This is in a fairly remote part of our system, so somebody had to go out, drive the whole thing, come back, come up with a game plan, go back out, figure out how, they started taking measurement. It was a process. We did it in one trip, and sometime between, I think we left the office at 9 and we're back by lunch. So it was about that fast. But the next example I wanted to use, and again, this is just an example of something that we've used it for in the past. By no means is this the most sophisticated thing we do with it. We got asked to put in a temporary overhead power line to serve a construction site that was going to be, they're building a new warehouse in an area where we were working. We got asked, okay, quick, we got to go out. We're going to throw this design together fast. They need power. We're making this happen. And we had some permitting concerns and some design concerns we had to get through. Again, under kind of our old modality, we would go out, we would have to kind of topo this area a little bit, figure out like where the ground is at, how we're going to have to get through there. This was compounded by the fact we had to cross a foreign utility provider in the interim. So I've got a picture here. So our utility line is on the left. This is our utility line over here, and we had a foreign utility on the right. For those of you that have ever designed utility lines before, you know that this is coming into a bit of a unique problem here. We have to maintain clearances from the ground. So we have the code book we have to keep track of, but we also have to maintain clearances from the foreign utility. You don't want to go over them because that creates issues on its own where if you accidentally fall into them, so you have to have a whole myriad of protection in place to make that happen. So we had a very narrow gap we were trying to shoot that went right through the middle of this. I'll hop back over here real quick and show this. Just a second here. So this is what we went out and ultimately wound up building. And I apologize if this doesn't come through incredibly clear on the webinar. we have our utility on the left, and we have the foreign utility on the right, and here's what we wound up doing. We needed to, before we started this project, hit these distances very specifically. So the engineering department had to tell operations kind of precisely how we're going to build this. That you can see over here, we have this pole that's sitting right here. We had to tell them how far down to frame that cross arm so that they would make clearance, and we would keep our required clearance from the ground to make it all work. So that's how we were going to bounce through there. One of the other in-house tools we use to design with this is taking that data from our drone, and we import it into, put this up here, we import that into AutoCAD. So with the drone, we went out and we flew our crossing. We flew the ground that we were going to be building over the top of here. And with AutoCAD Civil 3D, which digests DJI outputted data from their digital elevation model incredibly well. That was honestly, if I have to say, one part that genuinely surprised me was how compatible, just like DJI puts out a very rich and generic elevation file, a digital elevation model. AutoCAD Civil 3D digested it, and very quickly we came up with what the ground looked like, what the profile needed to be, and then we did a side shot profile. So here you can see our pole on the left. This is the foreign utility. There's the phase carrier, the neutral, where we needed to be, and how we designed that to fall through there. And then we continued to design out what the sag of that wire needed to look like. Here at the very end, you can see where we crossed the road. That was the road crossing right here, where you can see we came across the roadway. So in very short order, we were able to come up with the design, which we then sent out, and we came up with a set of permits that we handed in to our local government agency to make that happen. All in one flight. Took, honestly, with this particular flight, it took longer to get the drone out of the box than it did to do the flying. Consistently, that's the part that has impressed me, is just how fast we're able to pull back what normally took us, at minimum 45 minutes, an hour and a half, running around out there in the field, hopping fences, trying to figure out how to get into places to take points. The drone just made this so much easier. So to that, I'll jump to my last example here. So this is a section of line that we have on our system where we were experiencing what we will politely call some avian issues. And what those avian issues were specifically is this. Inside that yellow circle, I am not a great guesstimator, but I would guess at least 1,000 to 1,500 starlings, which is an invasive species where we live. And they all tend to land on power lines, because why not? So their impromptu bird perch happens to be over here by this red arrow, which kind of runs along this valley bottom here. The issue at hand that we run into is when all these birds in this picture land on our power lines and they take off all at once. They don't take off from all the power lines equally. So they'll unload from, say, the neutral wire before they unload from a phase wire, and then you'll get the phases slapping together, right? The phases will bounce against one another. We needed to get in here and lower the neutral wire. Again, we're staying above the legal minimums, but we needed to know how much room we had to come down and if this was possible. So this was, I won't say an emergency situation, but urgent. The operations department came to us at about 9 o'clock in the morning and said, this is a problem. We need to deal with it now. Let's come up with a game plan. And again, we went out, we flew this thing, and by noon we came back with the answer. So it was a rapid way to get this. What made this job particularly complicated is we were dealing with multiple landowners. You can kind of see in this picture, there's fences all over the place. Trying to hop over fences, get a hold of people, get permission, drive around inside of there. The field in front of us in the foreground here was all seeded, so we couldn't drive on it because the farmers had already planted winter wheat. Needing to get out over the top of this quickly meant either you had to traverse it by vehicle or some other means that would do it fast, and walking was going to take a long time because, again, this was several miles worth of line that we had to do this to. I did the math because I work in engineering, so of course I did. By the time you put 300 adult starlings weighing what I figured was about not quite 3 ounces, you had 51 pounds of birds taking off and bouncing the wire up and down, which was causing it to smack into each other. So we went out and we took some data on that. Let me show it here to you real quick. That looks like this. So we went in here, and this is the power line, and it was, you can kind of see the multiple fences that we had to cross in here. And again, same kind of idea. We came down in here and we took a bunch of measurements. I came in here, and the idea was to figure out what our minimum clearances and approaches were to the ground at each one of these, do a quick little temperature calculation, find out what the sag of the wire was in that moment, and then figure out how far down we could drag the wire to meet those clearances. Again, this thing flew, this whole profile was flown in 15 minutes, 12 minutes, something like that. It went very quickly. And again, and I'm noticing kind of a theme here, while we were doing this project, we ran into a tree trimming concern. We ran into a spot here, and the drone paints a very clear picture, particularly when you're looking at the point cloud data that comes out of it. We had a location in here where we very much needed to get the tree trimmers back out there for a contract that was finished to have a look at. So again, this worked out amazingly well. If I had to pin a word to it, I would say time savings. This has been a consistent theme for us in getting a hold of this. I think where a lot of people go with this often is, oh, you're at a utility and you have a drone. And as Chad shown in his presentation, there's a lot of inspection work that can take place with that, which is really cool. You can go out, you can get a ton of pictures, a lot of data, bring that back. You're finding missing cotter keys, things that are too hot, things that should be hot that aren't. That's important, and getting that big data back is a big deal. What is often overlooked, in my opinion, is the operation side of the business, trying to find those things that are broken. That's very valuable. On the engineering side, there is a ton of time savings to be had if you're looking at it as a design tool. And that's the one thing that I know that myself personally and our organization found out is just the amount of time savings through the different little processes we came up with, finding a lot of these things beforehand. Before we even sent people to the field, before the guys who build the power line even show up, we were able to get a large amount of data, and that really helped our design. So anyway, that's what I have. Back to you, Michael.
Awesome. Okay, so I'm looking, we have some questions. We got a bunch of questions I was able to answer offline, but I see some pretty important ones that I want to highlight so that everyone else could potentially see. So this one's for Chad. Is it your experience that oil and gas companies are more or less inclined toward UAV-based methane inspections compared to manned aircraft inspections? I've heard the point brought up that aircraft can cover more sites, areas quicker. What benefits might UAVs have over aircraft other than perhaps a more granular view?
I'm going to divert these questions to Jeff real quick. Jeff, could you take over for that?
Yeah, I got it, Chad. To answer that, Michael, so it depends if you're having a lot of inspections. Let's take, just use as an example, we'll take the Alyeska pipeline in Alaska. It's Trans-Alaska Pipeline. So that's 800 miles of pipeline that has to be, it's regulated as well. So I think that's got to be flown every 14 days, no longer than 21 days, and 800 miles. So with that, they're using helicopters to inspect that. And on the North Slope, you've got Greater Prudhoe Bay. We're talking over 5,000 miles of pipeline. So the aircraft is definitely better to use on distances like that, but for more specific areas you want to pinpoint, using a drone-mounted detection system is going to get you really a better data set. You can pick up more possible leaks with the drone, and you can pinpoint it easier than an aircraft, actually. So both of them are used in concert. They even have a truck, a FLIR truck up there with, it's about a $500,000 FLIR system. They'll drive the roads because this pipeline is regulated as well, and to pick up. So if you're looking at an instant like that, it's part of it's a tool you can use depending on what application you're needing it to do. So long distances, aircraft can do it probably quicker, but the drone seems to be more accurate. You can pick up probably, in my experience, you can pick up smaller leaks with a UAV than an aircraft, just due to the proximity of the leak. So I hope that answers your question, but it's a component in a system. So it's whatever your individual needs and uses are for it. It could be a helicopter, an aircraft, or a drone mounted with OGI detection, leak detection equipment, like the Ventus or the U-10. So hope that answers that one.
Yes, it does.
And I'd like to add to, overall accuracy and much stabler to operate some of these unmanned platforms in adverse conditions, i.e. wind and things where, it might not be safe to have a manned aircraft operating in those particular conditions, or even temperature-wise.
And on the North Slope, you're always fighting something up there. Generally, the normal wind, we've got 20-mile-an-hour winds generally. We're right there on the coast, if you could see, Arctic Ocean. So you've got elevation with, there's no problem with the elevation. It's all tundra up there. I think the Brooks Range is 120 miles away from where we were, but you could still see it. But you have low-lying fog constantly up there due to the temperature and the dew point constantly happens. There's just a lot of hazards up there too that prevent aircraft from flying. So I would think the UAV would be more appropriate in situations that you've got a specific job for it. You may have had miles of pipeline. You can break up flights and let you get a BD loss waiver and utilize that for longer distances as well. So.
Awesome. We'll go back and forth. I got another question for Brian. Somebody asked, only in what other ways do you foresee UAVs replacing the traditional party chief chairman duo in surveying for new pipelines and leases, or in general, specifically related to the oil and gas industry?
Okay, that's it. So to be clear, I work in power. So I deal primarily with overhead and underground utility power. I work side by side with some oil and gas guys. By then, it's down to companies like TransCanada and things like that. What I will say about how it's going to, I wouldn't use the word replace, and not because I shy away from it on the face of it. It allows you to be far more effective, far more quickly. I think what it is going to replace is the amount of time that those people spend prosecuting a single project. For us, we have the same number of people working here. What it's done is it's taken it so that we're doing things that we're better at now. We're designing more and faster than knocking on people's doors and trying to get into their backyards or trying to hop over fences. one of the biggest, and I didn't touch on it too much here, but one of the biggest things that it's helped us is to put a big bear hug around, we need to get from point A to point B. What is the best way to do that? Do we need to be over here? Do we need to be over here? This is a question that would take us sometimes months to go ascertain. We'd have to go out and talk with people and figure stuff out and, you know, get on their property and just do a whole bunch of things that weren't designing line or underground or overhead. It was all the other stuff that went along with that. And so now we can get a couple high altitude passes of this and go, oh, yep, that's not going to work. This is all here. And we can pull a particular routing or pathing out of the running months or weeks ahead of when we would have found that piece of information out later. So we have the same amount of people, but they're doing more of what they're better at and less of what it's kind of incidental to the job. We've gotten rid of a lot of the frills. I will say very briefly, tagging on to what Jeff and Chad just talked about. You talked about aircraft versus traditional manned aircraft versus unmanned aircraft. Let me throw this out there real fast. We have hired people to come in and give us aerial photography of an area of our system or to provide LiDAR data for a specific area. You had to call ahead. You had to find somebody that would do it. It was weather dependent. They had to find the time. They had to come from 100 miles away to do it. And if the weather sucked that day, you weren't going to get your data until the following week. Oh, and by the way, you get charged as this worked out. The drone allows you to surgically and very specifically pinpoint problems and get that thing, get the data that you need, and get back. Instead of go back, make a phone call, find the guy who can contract it. It allows you to get that data very quickly. In conclusion, I would say, don't think of the drone necessarily as a replacement for people per se. It's a tool that absolutely makes the people you have more effective, particularly if they can figure out how to integrate that with some of the processes they already have rolling. So. Michael, do you want me to grab that next question?
Yeah, go ahead.
So the question is, have we looked at the dock and the dock 3 as part of our substation, and how are we looking at privacy concerns with that? We have looked at the dock. It is something that we have kind of, we know this is something that we need to do to be able to get that kind of data. We haven't looked at the privacy concerns at it just yet. And that, just being honest, we're a small utility. We don't have a ton of people. This is something that has been posed to us a couple of times now. We see the value of it. We know it's something that will provide value to us, and in those critical times when we're trying to figure out why did this go offline at 2 o'clock in the morning, we very much want this data. We haven't had an opportunity to get in depth with it yet. In fact, it's kind of funny. Before we started today, Michael and I were talking about that, how we need to, I need to get more schooled up in that and carry our drone program a little further. And I would very much like to become more knowledgeable in that area. So sorry, I wish I could be a little more help.
Okay, and then one more question for Jeff. This one was, have companies been using UAV-based GPR, the ground penetrating radar, for U/G line locating as a replacement to traditional line locating, or is that more of a supplement?
I would call it, depends on what you're looking for. If the reason we use it, I can give you our user case for it. Up there, we've got a lot of that place is tundra. And there are certain times of the year you can go on there. You need to get a permit to go on there. It's highly regulated. You just don't walk out on to the tundra. So when we got the GPR, we were using it specifically to, as Chad mentioned earlier, search for underground infrastructure. So if we were going to put underground power lines in there or whatever, and we can take those data sets that we gathered from the GPR scans, convert them into shape files, and implant them in our GIS system as a layer. So we can pull that layer up for known locations of underground infrastructure that we may not have had, because that place has been, they started up there in the 70s. So a lot of the data sets, there are none. And the ones we do have are good, but it's a lot of it's old data. And but to get more specific on your question, it's probably easier to locate in other ways. The GPR takes quite a bit of time to really interpret the data and get good at it. It's just not a plug and play device you can plug up and go fly an area and get data sets out of it. It's very specific flight profiles you've got to fly, and you're very, very low to the ground. The tundra, coming back to that, if we needed to go out onto the tundra, it's a lot easier for us to take the GPR out there, set a flight plan up, and let it fly it. No one has to go out there and bring back and get our data sets and process them. So to answer the question, I would call it's probably a component in a system, like I mentioned earlier with the optical gas imaging, and it's component in a system. It depends on what you're trying to locate. So if you're looking at pipeline in the mountains, probably, if it's wired, you can hook a wire up and a locator up and send the beam through there and locate it manually, or in more flat areas, the GPR is probably a better option for you. So that's through my experience. So I've done both. So
awesome. I got one more question for both of you guys, Brian and Jeff. I think this might be one of the last questions, but how long from the drone getting back to the station, like they flew your mission and then, you see all these issues, till you can get an actual human to get out there and do a repair? What's the process like?
So on our side, when we go out and fly, we're bringing the data back pretty quickly. Like we try to time our flying so that it fits when we have decent weather. So for us, that's going to be, probably I'd say 8:30, 9 o'clock in the morning to about 1, 2 o'clock in the afternoon. The wind starts picking up a little bit after that. Drone flies really well in the wind, but I'm chicken. I don't want to crash it, so I generally try to fly earlier in the day. When we get that data back, we'll see a problem pretty quickly. Like it'll show up big and bold. I usually can get a service order together in a few minutes and poke it over to the line crew side and say, hey, we got to get this fixed. After that, they kind of grade it by severity. If it's a big deal, which we found a couple of those, they'll go handle it right then and there. If it's more of a minor annoyance, like if it was a trash bag that blew up into the line, they're probably going to go deal with that pretty fast. But if it's like if we have like a missing cotter key or something like that, they'll go catch it like the next day or later that week. But on our end, we can get the data back to them within usually about an hour of when we land. Just kind of depends on when we get back to the office, if I have lunch first.
Awesome. Jeff, if you have any input on that, when you guys see an issue, how long does it take?
All right, whether it's a gas leak, which would probably be more pertinent, we catch a major gas leak, we can make a phone call and do it immediately. We don't play around with that. So and the power grid up there, I mean, that's the heartbeat of the field up there is the power. No power, you're not producing oil. And so any issues we find that we see visually when we're flying the power grid, we can make a phone call as well and get T&D out there to take a look at it and correct it. But generally, we catch stuff when we're doing our processing of the data sets. When we see something that we didn't see visually in the field, we can call and send the actual data set to the T&D guys and the engineers and let them decide, hey, we better get out there and correct this, or it's in their hands now, but at least we've alerted them to it. So the time frame on that's generally pretty quick. Little bit longer when we have to process the data and then start getting the results from that, unless we catch it in post. So power line's a little varied, but for gas, we can do that immediately on a big leak. So.
Okay, thank you so much, Jeff. I feel like I've answered a lot of the questions, either offline, some of the smaller questions, or the bigger ones we've had answered the team. So I want to thank everyone so much. Like I said, this will be recorded and be sent out. Thank you so much for joining today's webinar. I really appreciate it. Everyone have a great day. Bye-bye.